So on the bench today, we have an item I picked up on eBay recently. It was a buy it now. The price seemed right. It looked very interesting to me, and so I just went ahead and grabbed it without knowing a lot about it. It's extremely heavy. It's got a large linear supply. Hopefully it'll come into focus. It is dual full height 5 1/4 inch floppy drives. It looks to be in really good shape. There's a tag here that says Indian. It's hard to read. Indian Wells Valley Insurance. Indian Wells Valley Insurance in Connecticut. The tag doesn't have an area code. It's just got a phone number, which helps date this. It's been around a long time. There is a sticker on the side to copy updated programs. Pip C equals D colon blah 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 blah. So using pip, it most likely was a CPM machine. The backside's interesting. Oh, that's what's been rattling around inside, I suspect. Is both drives seem to have their own edge connector broke out. They are gold plated, which is nice. And of course, power switch and fuse. You know as much about it at this point as I do. The rubber feet are long lost. But at this point, I think let's take the case off and see what we've got. So, looks like there's 3 screws on each side. They're coming out relatively easy. I can see through the air vents. There's a very large transformer inside of there. Like I say, I'm pretty sure, based on the weight, it's a linear power supply. It's certainly heavy enough. Yeah, that rattle it was making has stopped, and that nut has fallen out. So that's what I heard rattling around inside. It was shipped with a floppy in each drive, which is nice. So the heads were loaded. So they weren't necessarily going to slam together due to impact. So whoever did that, I appreciate it. It looked like looking down through the front slot, they're double-sided drives, but we'll know for sure once we get it open and get a closer look at the drives. So with the rubber feet gone, this should, with a little bit of tension, slide up off. I can already tell they're double-sided drives, at least the one I can fully see is. I'll explain how I know that very quickly here. So 5 and 6 are the heads. On a single-sided drive, only one of these is populated. On a double-sided, both are populated. So one head and the other head. So these are, like I say, it's a double-sided drive. I'm going to assume they are 40 track. So 360K drives. This board is interesting. There's where the nut goes. Based on how that rocks, that nut is potentially missing, or, well, maybe not. Oh no, yeah, that nut has vibrated loose. So each has an independent power supply, it looks like. It's quite interesting inside. Let's tear a little further into it. Those capacitors failed? Is that what I'm seeing? Huh. 3 of these 4 orange caps have that kind of boiled up out of them in about the same spot, as if, and this one's just starting to do it. I think those caps have aged poorly and have failed. Isn't that interesting? So this may require a power supply rebuild. Let's see if we can remove one of the power supply blocks. Looks like these are pretty easy to tear down. That releases that whole board. I need to pull the cable off of the drive. And the last thing that's wired up here is that mess, and that is a mess looking at it. Let me find something to cut that wire tie with. Oh yeah, all these capacitors, I can see one down here have that same weird, I would say they are all bad. Man, I just placed an order on DigiKey this morning for capacitors for a different project. And it looks like I'm going to need capacitors for this one. So color coding is interesting. So there is 4 diodes, so there is a bridge. So it looks like the lead with the stripes. This is an interesting way to build this. Goes to what I'm going to consider the earth grounds, and then there's actually that's the center. So what the stripe is going to be the center of the. It's got to be a center tap transformer. That's what I'm looking at here. Is those inputs are coming off of a center tap transformer. I absolutely see what I'm or see it now. We'll get a little further in and look a little closer at that. There is the screw that went with that random nut that fell out of it that's floating around back here. I'm getting heatsink compound on me. Ah, these. Okay, that's an interesting design. We'll look at that design choice. I need to release these if I can. Pull that out of there without destroying the PCB. Oh my God, that's tight. The floppy 34-pin cable, if I can get in there to get it off. It's probably never been off that drive since that drive was, or since the cable was put on back originally. Oh man, there it is. I think that'll free this entire module to lift out of here once I untangle that cable, and it does. I'm getting heatsink compound all over me. So what we're seeing here is there's a 7805 and a 7912. It doesn't make sense. It's got to be a 7812. 7805. So okay, 7805, 7812. So it's got 3-pin linear regulators on this little metal tab that's bent 90 degrees, and then heatsink compound to the back and side of the case. So that is the heatsink solution for this. Let's get a wipe here and clean this off before I get old dead heatsink compound spread everywhere. You go far enough back in heatsink compound, some of it can have some pretty nasty metals in it. At least that's what I've read, that you really don't want on your skin. I think something like this coming from, we'll see if we can date it, late 70s, early 80s maybe. The pip command's a giveaway there. This was a CPM machine. It may have been an S100 machine for all we know. It's probably new enough that you don't need to worry about there being something toxic in the heatsink compound, but that doesn't mean, lick it off the case. But let's get it cleaned out of here. When we eventually reassemble this, we will want to refresh this anyhow. This is really dried out and aged. I think I can use the other pad to kind of finish that up. Those capacitors have certainly spit their guts out. It's quite interesting and odd. It looks like bird poop. There's a little bit of it here. We can see that all 3 of these have discharged this, and here, and 2 of the 3 here have. So these were Siemens 2200 microfarad 40 volt caps. I think they're probably all going to be identical. 2240 volt, 40 volt. I think they are all identical. No surprise. I don't know if I have anything I can use to replace them or not. I am first thing, because I don't see any silk screen, going to indicate capacitor polarity on here. That's plus. It's a really bad plus sign. That's plus. And this is plus over here. Plus. And this is plus over here. I'm just starting to see how these are put together. That's really interesting, that the way that cable loom is soldered to the back of this board, soldered to the front of this board to create this. So this could be a single drive assembly or a dual drive assembly, depending on what you bought, using the same boards. I'm going to fire up the desoldering tool, and we're just going to remove these capacitors as a matter of course here. They just need to go bye-bye. We get them out, we'll test one, but I'm very sure with the paper burst, it's almost like the alien bursting out. It looks on this one, I can actually see that the paper has burst, I think, where that has erupted out. I mean, these caps are definitely gone. They're Siemens. They should have been decent quality. At least I would assume they were. Siemens to me is a quality name. Definitely very much, very recognizable drive to me. That's interesting. So there's the configuration jumper here, and rather than actually cut the traces, they've bent the pins out. So that is the configuration jumper. I believe drive select happens there. This is termination. Termination resistor pack, as I remember on these. I'm going to have to go look up the data sheet. We know that on the side of the box it said copy C to D, I believe, on the side of the case. Wherever I put the side of the case, there it is. Pip C equals D colon. I am... I don't know. I don't know what drive is which. So, definitely early drives. Are there date codes on the parts here? Second week of 84. 43rd week of 83. 37th week of 83. So 1983, 84 would be the era this is from. Let's see if we can actually clear these from the one side. Nope. Too much solder on the other side of the board. So let me heat up the soldering pencil, and we'll manually remove those, and then use the tool to clean up behind. So let that get up to temp. I should be able to do exactly that. Just kind of, once it's released, just pull it up out of there. And I don't want to damage the board here, will you? Oh. Actually, with those out now, because it's not 100% obvious, I'm going to mark where the negative side soldered in as well, just because there's additional traces, especially on this guy down here. There's additional holes, and it's not exactly clear which holes the capacitor mounted to. So, you know, I may have appropriate capacitors we can just swap in here in my stock. And I may not. I don't honestly know. I don't think the capacitance of these, well, I know it's not critical. Probably don't want to go much smaller. There's a reason they're this large. But I would think anything in kind of this range would be absolutely fine. See, I'm guessing these are in parallel. The two big ones there are definitely in parallel. I can see through, the board to the traces underneath. Let's see if we can get sufficient room to get in here and release this guy. This is negative, this is negative, and this is negative. It should be easy enough to remember how to put those back together. Boy, that capacitor gunk is just ending up everywhere. Man, that's nasty, whatever that is. I'm glad I didn't just go, well, let's just power it up and see what happens. It's definitely firm. I wonder if there's the way they, all but one of them have failed in the same way makes me think there's an intentional vent there. That was specifically to when these had, finally failed to vent. Yeah, that's a mess. Let's see what our handy dandy peak ESR meter says. Let's find the one that wasn't spitting its guts out is this guy. .16 ohms, 2250 microfarad. So that's probably a reasonably good cap. What does it think of these? 0.5 ohms. The capacitance is a little high. 0.5 ohms is definitely, in my mind, above what you want to see here. The higher that resistance, the more heat the capacitor will dissipate. I always get this backwards, but I researched it again last night for a different project. And lower resistance is typically better because there's less resistance to the current flowing in the cap, so it doesn't produce as much heat. So, yeah, 1.87 ohms, that is a bad cap. Even given the size of it, I believe we can just still call that a bad cap. 2.8 ohms. Do I actually have the sheet here? I do. This is for a different project, but we're talking ESR here. These are 2200 microfarads, so they're right here. They are rated at 40 volts, so they'd be in here. So it's expecting to see between 0.05 and 0.04 ohms is what I'd expect to see. And we're seeing 2.8. That's a bad cap. In anybody's book, that is a bad capacitor. This one is probably bad. It's just better. 0.14, it's on its way out. So, oops, off. So we've got bad caps. No surprise. They gave us a really good visual indication that they were bad. They most certainly did. Looking at the design here, there's that largest transformer I talked about. It's a center tap. So the lead here with the yellow around it is the center tap. And then there's, the two outside of the center tap. I'm assuming you understand what a center tap transformer is. Maybe you don't. I don't know. I need to put those into electronics recycle. I'm sure somebody will want to do, well, maybe they'll do aluminum reclaim on those. I have no clue. I have no clue what actually happens to old caps. Let's get rid of whatever that is, and hopefully it's not toxic, because I'm touching it with my bare hands. With my luck, it's extremely toxic. Anyhow, it's a center tap transformer, meaning in reference to this lead, you're going to have positive voltage and negative voltage, with this lead being reference in one half of the cycle, and then those will swap the other half of the cycle. And then you're using the diode bridge to, why are they using a center tap transformer here? Why? This isn't producing a negative voltage rail, it's only producing a positive voltage rail. Are they using one half of the cycle for one of the regulators and the other half for the other? Maybe. Are the capacitors completely in parallel? Those two are. That's common. Ah, I see what they're doing. Okay. They're using one of the sides of the transformer as reference. I'm going to be ground. And then they're going to use this one here, and say this is a 12-volt center tap transformer. So if I'm using this lead as ground, and it's 12-volt center tap, this is going to be about 6 volts on this lead, and it's going to be 12 volts on this lead. Actually, let's make it a 20-volt transformer. We could measure it, I guess, but let's call it a 20-volt. I've got the far side here is ground, around 10 volts on here, and 20 on here. And so we're regulating that 10 volts to produce the +5 rail, and the 20 volts down to 12 to produce the +12 volt rail. And that way, we're not dumping huge amounts of heat out of that 7805 regulator. We've talked about this before with voltage regulators, where the higher the delta voltage between input and output, the more heat the regulator needs to dissipate in order to get rid of that excess voltage. That excess voltage is converted to heat. That's what it does. If you put 10 volts into a 7805 and you get 5 volts out, and you're drawing 1 amp, you've got to get rid of 5 volts someplace at 1 amp, and 5 times 1 is 5 watts, and you're dumping 5 watts out of that 7805. That excess voltage has to go someplace. So that's the screw that was loose back in place. We're going to clean these up. If we've got enough solder left to clean it up. I may want to put some fresh solder on these. Oh, that one cleaned out well. How about from the other side, because there's lots of excess solder on this side. That cleans him up. Let's see if we can do the same on this one. So what's happening here is I'm not getting the heat all the way through to the other side of the board, and that's why the tool sounds like it's having trouble drawing vacuum, because the via isn't open all the way through. I will probably drop these as is into the ultrasonic cleaner. And that'll knock all that nastiness from the cap leakage off. There's one that goes from here down to here. Interesting. What an interesting way to do this. Anything else to say here? You know, the signals are just passed straight through to the connector. I'm not sure there's much more to add here. We will recap these in a future video. This one's probably gotten long enough. We'll look at doing that probably in the next video. So I'll wrap this one up here, and I'll see you in a future video as we rebuild this guy.